Hi, I'm Chuck, and today I'm going to do a review on the Modix Big 120X 3D printer. So this is the Modix Big 120X, and I've now had this thing for just over 2 years. I've got a ton of experience with it, so I feel really good about giving an honest and thorough review on how awesome of a printer this is. It's a kit printer. It comes from Israel, and the folks at Modix have been extremely good to me as far as support, extra parts if I needed those, software suggestions, and just general troubleshooting items. The support from the very beginning on putting it together was great because it is a kit. You do have to put it together. And overall, I just can't say anything negative about the support that I've received from Modix itself. Now, prior to working with these printers, the printer that I had was a Zortrax, which I still have, and it could do something that was like maybe an 8" by 8" by 8" object, and that was pretty useful for a lot of small things that I was doing. And actually, I still use that printer for some more of the fine stuff. If I need a part that I could just simply print with that one versus printing it on the big machine and taking that machine offline for something that I could use to print something bigger. Additionally, the Zortrax would print things that are a bit more fine than the Big 120X, getting down to a lot better layer height. This is a big printer. So as far as the size of this printer goes, this is a really big bad boy right here, because you can print objects that are literally 2 feet wide, 2 feet high, and 4 feet long. And it is an absolutely huge build volume on the inside. Additionally, on this particular machine, I bought the full enclosure as well. I now made some modifications to it in order to fit my office, my garage office, and how I wanted it to do. Now, normally on this machine, I have it slid up against this wall over here, but I slid it out to do a little bit of maintenance on it, but also to record this video. I do know, starting at the bottom, that some people have put in casters on the bottom of theirs. With mine, I've never really needed the casters. I don't have to move it very often. And just to make sure it stays completely stabilized, I wanted it to sit flat. So all I simply did on the bottom of mine, because I've got a very nice floor finish in here anyway, is just put a couple small pieces of cardboard really on the bottom, and the thing slides right out quite easily here. Now, if you're in a garage where you've got concrete and it's rough, then yeah, obviously you may want to find something to put it on top of so you can roll it around. But I haven't had that problem here. The other thing that's pretty noticeable about this printer is the top. And you'll notice that in my top, I actually have a couple of cutouts that I created. And the reason why I did that was because I've got a full enclosure in here. I was trying to find a nice, easy way to get my material into the machine. And initially, I had thought about drilling a small hole in the top so I could keep it as tight as possible, but I ended up cracking the acrylic and then came up with the idea of making a square insert piece. And so the way that works goes hand in hand with the mounts that I have for rolling material. So the first thing that I did was I realized when the machine came in, it had tons of extra parts, and I kept getting a dragging issue on rolling material from the side into the machine. So probably that was user error at the time. But what I came up with was with the extra bars that came with it, I created this nice setup here that runs on both sides, and then T's in the middle, and then I can hang material from the top, and then it'll easily go down into the machine through these holes, which you have to have 2 of in case the top is actually open or if you want to open it. right? And then I have little lids that I can actually put on top of here if I wanted to as well. But the temperature inside tends to stay exactly where I want it to actually be with the lids open. The other modification that I made, which is a little bit unrelated to the Modix, is I built a shelf up top against the wall. And there I have my print dryer. I actually have two print dryers, so I can put big spools up there. The machine runs on 1.75 millimeter material, and I've got stuff that currently I'm running a part that's going to take pretty much exactly 1 kilogram. So it's a smaller piece. But as you can see in the print dryer that I have up top here, I've got a giant 5 kilogram roll. And what I'll do up there is I was able to, using the machine, 3D print an extra piece on top of this print dry so I could put the lid on top, and came up a way, which I have a video on, of rolling material out of here so that it rolls nice and easy. And now I can actually run prints for up to 5 kilogram, basically the equivalent of 5 kilogram rolls of these, so I don't have to actually change the material out, right? Okay, so going back to the machine itself, I've got the lid down. I'm in the middle of a print. And as you can see on this print, I've got a decent sized print going right now. This is a lower, and I'll show that example in a few minutes. And this is running a 0.8 millimeter nozzle on it. Now, I have now run the 0.4 millimeter nozzles. I've run 0.8 millimeter nozzles. I've run 1.2 millimeter nozzles. I've run brass nozzles, steel nozzles, and ruby tip nozzles, the Olson Ruby. What I have found is the best bang for the buck on time and quality is the 0.8 millimeter nozzle, running anywhere from a 0.4 millimeter layer height to a 0.6 millimeter layer height. In this particular print, we're running at a 0.5 millimeter layer height, and you can actually see the detail on this looks extremely good. And this is after a really good calibration. Now, another modification that I made to my printer is I added in some cameras. Now, I know that there's some cameras that people have that work with their computers, but I really like Arlo home security cameras for my house. And what's great about these Arlos is that they're magnetic, obviously, and I can put them pretty much anywhere in the machine. So right now I can actually monitor this machine remotely with this camera, and then I can just put one anywhere on the print, right? So using the Arlo, if I wanted to, I could open this up if I want a different angle. I can just take it and stick it over here and watch it over on that side, And then this one, of course, is completely adjustable based on how it magnetically attaches. And that setup can work on any one of the corners, so you could actually have 4 different angles going on the printer at any time. Another modification that I did was on holding the lid up by having this thing set up so that I've got the bar going across the top here. I can actually, using a bungee cord here, right? I can actually lift my lid up and attach it that way and hold the lid up if I need to get in there and do something, right? And then at the top, as you can see, I've got another little T up at the top. And what that's for is if I want to add another Arlo camera, if I want to actually look at my material, I can actually watch my material remotely as well. Now, as far as electrical requirements go, this machine, mine runs on 110, 120 volts. This is in the US. And I haven't had any major issues with that. The only problem that I've had is a couple of times I've tripped breakers, not because of the machine itself, but because of the machine and everything else that I have plugged in to the breaker on this wall over here that you can see in the corner. So I had to actually run something out from the machine as well. So the heaters on this thing take some power, right? That's where most of your power is going to be, is on these heaters on the bottom, right? Because those things I've had as high as 130 degrees Celsius. So they get pretty hot. I mean, that's well above boiling for those of you guys that can't do the conversion in your head. So it gets hot in here, okay? And that takes some power to get these huge pieces of aluminum up to that heat. Additionally, you've got the printer running, right? It's moving around. And then I've got LED lights that I've added inside the bed to light the thing up if in case I have all the lights out inside the house. And you have the computer running. And then if you have a computer that you're monitoring things with too, well, you got that running too. So that takes up a decent amount of power. So you may want to keep in mind that you're probably going to need 2 breakers of 15 amps apiece to run this machine. Now on the assembly time on the machine, expect to spend some time putting this thing together because you're saving a ton of money. When I was pricing out large machines, something similar sizes, I was looking at probably spending $20,000 to $30,000 on a big 3D printer because I had a really big project that I wanted to work on and I needed a printer to be able to do that. So this machine was somewhere, it was right around $8,000 or so, $8,000 to $9,000 total. And all the parts came shipped in from Modix. I wasn't short anything, so everything came in. If anything, I had, like I said, tons of parts left over. I got a lot of bolts and a lot of screws, and also some additional bars that I used for additional supports, and I still have a few left over actually on top of that. There was a couple extra pieces of acrylic, and there were a couple pieces that I never figured out what they went to. So as far as the actual time to put this thing together, it took me a little while because I had no clue what I was doing. I didn't know what the XY axis bar looked like or anything else. So if I had to, so first time putting this together, knowing virtually nothing about 3D printers, I want to say it took me about 60 hours of build time to put it together. Now, if I had to do the whole thing all over again with the next machine that I get, I could probably do it in about 20, 25 hours. So it'll take a little while to put it together, but again, you have to think about the cost savings that they're actually that you're seeing versus buying one put together. You know, if it bothers you too much and you don't want to do it, feel free to contact me. I'll come put it together for you. Okay, so let's talk about the software that you can use for this thing. Modix recommends or recommended at that time using Pronterface to set the machine up and to help with calibration. I still use that now to level off the machine and set my Z height. But that's it. That's the only thing I use the Pronterface for. Outside of that, design-wise, I use Fusion 360, which has been wonderful, especially since it's got such a good memory on it on the timeline. I've done tons and tons and tons of designs with here, tons of different types of prints as well. Some really, really neat stuff that you just simply can't get. It's also works with my virtual reality headset, so I actually do designs with my virtual reality headset, and then I can bring them in as an OBJ file and modify them from there. So that's what I would recommend for using as far as your CAD software on what you want to design with. As you can see here, I'm actually designing a garage. Well, actually, I have a garage, but I'm laying out how I want my setup to be in the new garage with motorcycles and outdoor kitchen and stuff all in 3D, so I can get things to fit right. But I've got, obviously other stuff as well, including this print that I'm doing right now. Now, you can't print from Fusion 360, but you can convert that over to an STL file, which then I bring into Simplify 3D. And Simplify 3D is extremely good, a very good slicing program. And I've been using it now for about 1.5 years and much nicer than the one that I had before. As you can see, like I'm running this print right here and using a 0.8 nozzle with 0.5 millimeter heights, running at a 2400 millimeter per minute runtime. We're looking at 27 hours on this big print. So let's talk about calibrating this machine. A lot can go wrong when you're dealing with a big build plate. Remember, we're talking 4 feet from here all the way down to this other end. So if you're off by a couple of millimeters from one side to the other, you may see it in your prints, okay? So you want to take the time to get this thing calibrated correctly each and every time you go do a big print, okay? I do it every time I go to print. It takes me less than 5 minutes to calibrate the whole thing, and my quality of my prints have been wonderful. You don't throw away material as much, so just take the time to do that, okay? And they even send you, they send you this little piece of metal, which is exactly 3 millimeters thick. And when you go through the process of calibrating the machine, it's going to run the print head to the center, bring up the build plate. and then set it at 10 millimeters right off the bat. And then you're just going to want to lower it to 3 millimeters. And you know what? I don't even set this at 3 millimeters because the printer usually ends up with like a slight lower warp in the center just because of how heavy it is. So I just get it down to make sure that it's somewhere right around here. And then I just calibrate the four sides, the four corners, right? And the order that I do this, which speeds up the process significantly, is I take it and I send it to the front left first, okay? And there's a reason why I do that. So I bring it to the front left, calibrate it at 3 millimeters, then I run it to the back left, calibrate it to the 3 millimeters, and you calibrate these things just by going down manually to the actual knobs that you see with the belts at the lower part of the Z-axis controls. Okay, and this has four of them: 1, 2, and 3, and 4. Okay, not 3 like its little brother has, but 4. Okay, so you set the piece of metal here, calibration on the bed, lower the print head or raise it by adjusting, turning the knob a little bit till you can slide this underneath. And you can see the paint a little bit scratched from me just rubbing back underneath. And then bring it back to the front left, then run it over to the front right, calibrate that spot, then run it to the back right, okay? And once I've done calibrating those 4, then I bring it back to the front right, double check calibration, bring it back to the front left, double check calibration, back to the back left, double check calibration, and I'm good to go. Okay, so again, the order is once you get it set to about 3 millimeters in the center, run it to the front left, front right, back left, front right, front left, back left, and you're done. Okay, now I've had times where I've come in here afterwards, and for some reason the thing's like way off. I mean, like the right hand side is down quite a bit compared to the left hand side. And in that case, I'll drop this thing in there and slowly raise them up until they're in the general range. And then I might run through that process 2 times just to make sure it's 100% accurate. If you use something super fine, like a 0.4 nozzle and maybe, I don't know, like a 0.2 layer height or something, you may want to run through it a couple of times, but usually 1 time is enough. Okay, so as far as monitoring the machine, things that you can do to it to control it remotely. One of the things that my goal has been with this machine is to be able to do a large part and not sit here for days and days and watch this thing, because I've printed stuff that's taken 2 weeks to print, okay? And I've got things that I want to do, places that I want to go, and I don't want to worry about this machine messing up and that come back and there's tons of material that's been wasted. When you're dealing with 1 kilogram spools, that's one thing, that's like 20 bucks. But when you're dealing with a 5 kilogram spool, now you're talking about some money, right? This thing keeps on going and spitting out stuff, right? So there's 3 things that I've added to this machine that has helped me do things remotely with it. The first thing is, as I talked about earlier, I've got Arlo cameras in my machine, okay? And you can use others as well. Just plan on putting some cameras in there, but the Arlos are great, like I said, because they're wireless and they're good high definition, and I can take the camera and I can move it anywhere I want. I don't have to worry about wires on it, all right? And they're very good inside this machine as far as the temperature goes, right? The second thing that I've done is on my computer itself. So I've got Log Me In, so I can log in remotely, and I can actually pause the machine from the software that's whatever slicer software you're actually using. That's if it's actually plugged in, right? So this particular machine is not a Wi-Fi machine. It plugs into a USB of the actual computer. So if I have it plugged in, then if I'm going to use Simplified 3D, there's an emergency stop button, or you can pause it. Or even if you have a pronter face running, you can send a command to the G code and you can actually pause the machine. And then when you get back, then you can see what happened, or if you ran out of material or whatever, and keep on going, okay? But if it's disconnected like this is, well, then what happens is remotely, I'll just stop the machine, okay? Now, how do you stop the machine? Well, I kill the power, right? And the way I do that is I added these Wemo switches from Belkin, right? And you don't have to use Wemo. There's lots of other ones that are out there. So I have 3 Wemo switches on this machine, okay? I've got one that controls the power to the actual machine itself. I've got one that's used for the left build plate, and I've got one that's used for the right build plate, okay? So again, this is one of the reasons why I had the machine moved away from the wall. There's a lot of wires in here, okay? And what's great about this is that I can shut the power off to the heater on the build plates remotely, and I can shut the power off to the machine in an emergency situation. So if I'm out of town and I'm watching a print and I check on it periodically, or my wife tells me that it's not going well if I have her check on it or one of the kids, then I can just simply kill the power to the machine. But the other thing that's neat is that sometimes you're printing stuff, I'm printing something and I'm out of town and it gets done, or or another example would be I've gone to bed and it's going to get done at like 1 o'clock in the morning or something, and I want to kill the power to the heated build plate so it's cooled down when I get back. So I can actually kill the power to the build plate remotely through the software with Wemo, and just tell it shut power off. Just no different than shutting a light switch off. Your outdoor lights at night. So I can shut the power off to the build plates, and the machine can at a certain time the machine can finish printing and then it's cooled down. Or if the simplified 3D software gives me an estimate that the printer is going to be done at 1 o'clock in the morning, then I'll give it a little bit of a safety factor, and I'll have the printer shut off at 2 o'clock in the morning, right? And that way I get up in the morning, it's completely cooled down, and I can pull my material off. So as far as durability goes, I have torn this machine up so many times in learning how to print big parts. It's crazy, okay? But I've also learned a lot on how to repair it. Virtually any parts that you break, of course, you can get them from Modix. They can tell you where to get them. You can buy them from E3DM or wherever online. But the great majority of parts, I've been able to get on Amazon, right? Virtually anything that's gone wrong, I've been able to get on Amazon. As far as run time goes, I actually had this thing going on a hardtop convertible that I created using PETG for almost 9 months, okay? Non-stop running for 9 months, with the exception of if something broke or something went wrong. Okay, so in 2 years, in over 2 years of using the machine, and in all of that, I've not had to replace a belt once. Not one time have I replaced a belt. Okay, a couple of things that I've had to replace on it from wear and tear is the rail cartridges that run back and forth. I've never had to replace the Y rail cartridge, but the X ones I've replaced a couple of times. All right, those rail cartridges go through some use. All right, so if you get those in, depending on which ones you get, there's some ceramic bearings that you can replace the stainless steel ball bearings that come with most of the rail cartridges. If they're Chinese made, get the ceramic ones and they'll last a heck of a lot longer. Okay. But as far as actually fully replacing the cartridges, one time I've had to replace, I just went ahead and replaced both X cartridges because I thought maybe that might be what my issue was. Okay. Second thing is if you ever hear a clicking noise, right? When you're doing your calibration, that's a good time to listen for noises. So there's one spot that I continue to have a little bit of an issue with every once in a while, like every couple of months or so. But now I know what it sounds like. I can go get it. And that is on the X-axis, the far back left. That corner back there has a lot of power going through it, right? So this belt is pulling really hard to move this thing. And if you've got this thing running at a super fast speed, and I mean like you're talking 6,000 millimeters per minute, which I've had it up to before, it'll print. It'll print that fast. But it will wear this thing out as it's moving back and forth. And the piece that gets worn the most is the gear in the back here. Where you see this belt running back in there, you may be able to see it, but I've replaced mine with a brass gear. It was kind of like an aluminum sort of plastic sort of thing, and that broke, and the machine was still running, but it was making clicking noises, and I couldn't figure out what was wrong with my prints, okay? As far as the push bearings go, I haven't had any problems with those, and I haven't had any problem with the front gear at all either, but I went ahead and replaced it since I had to take the machine apart. So because of that, there's probably some pieces that you're going to want as extras. What I would go ahead and do, and it's short money, especially if you just spent thousands and thousands of dollars on a machine, is get some of the key parts that you might end up having to replace at some point. So the first thing I would do is I'd get 2 or 3 rail cartridges, okay? You're only looking at 3 on the machine. They're not very expensive. Um, you may want to go ahead and order, like I said, ceramic bearings. I think they're 5/32, but there's a video on that. And have those in case you want to replace those. It's not a huge process to do. So definitely I would go ahead and get at least a couple of rail cartridges just in case something wears out or the bearings go all over the place or something and you need something to replace it with. The second thing is I would go ahead and get a couple of the gears for these corners back here. All right. In both cases, you can get them in brass on Amazon, and those, if you want to replace those at the beginning, go ahead. If not, then if you start hearing a clicking noise, like I said, you'll start hear this click, click noise every once in a while. Everything else is working fine, but your print quality is just not there, and it's coming from that back left. It's probably that gear. Now, either the gear is broken, or sometimes the set screw comes loose too, right? And so if it's a set screw, you can do that pretty quick, right? That's really easy. You can reach in from the back of the machine and get to it. But if it's the gear, you got to take this whole thing apart in order to get the entire actually x-axis rod out. And then you want to make sure that you take your time with that in case, because of the push bearings and things like that, okay? Third thing I would get is I would get a full set of push bearings for this left-hand side, for the x-axis also. And in there's only a few of them. There's like, I don't know, 1, 2, 3, 4. There's like 4. So just get 4 sets of the push bearings for that. So that way, if something happens with those, you've got a full set to go to. Obviously, you're going to want to have an extra nozzle or two. I have found that on the brass nozzles, they do wear out, especially doing a lot of big prints. And if I'm doing like, a couple of giant prints, I'll just toss it after a couple of huge prints and just throw a new one in versus getting, much more expensive nozzle. When you're talking going through several $100s worth of material and the nozzle's like $6 or $4 or whatever, just get a new nozzle. So not a heck of a lot going wrong with this thing. There's only one real issue that I spent a long time trying to figure out why my prints weren't printing right. The prints kept warping up on the ends no matter what I did. And my temperature was right. Like, I'm running at 110 degrees Celsius right now. And the monitor says that the build plate's at 111 on the left-hand side, and the right-hand side I'm not using, so there's no point in heating that. But what happened was after a month of just trying to find some way to stick these things down, the prints down, and knowing that my temperature was correct, I finally found out that the heating pad had failed underneath here. This heating pad had actually gone out, okay? So it was heating. When I would touch it, it would warm, but it wouldn't get above about 50 or 60 degrees Celsius. And I'm trying to print stuff that's not going to warp like ABS, because ABS does warp, and I need it to be over 100 degrees Celsius for it to stick to the build plate. And the way I found that out one day was after printing, I finally happened to accidentally touch it and realized it wasn't super hot, okay? And I talked to the guys at Modix, and it was under warranty. I got a brand new one sent to me in no time at all, stuck it on there, haven't had a problem since. You can even see here on this guy that this is ABS, right? And it's sticking. It's sticking extremely good to this aluminum build plate, just using slurry. That's all I use on here, okay? So what I do now is, as you can see, when I put as the printer starts up and I'm getting ready and the build plate's heating up, I put a couple of pieces of blue tape on here, and I use a laser thermometer to check those temperatures just to make sure my build plate is the right actual temperature, right? Is the temperature of the build plate what it's actually saying here on the digital display for the heater, okay? And I haven't had any problems with that in about a year now, okay? So an example of things that can be printed, again, it's sky's the limit on something that's going to be huge. If it can fit inside that space, you can print it. right? You may have to figure out how to orient it to reduce your warping on it, right? Because that's just how the materials work. But you can do stuff like, as you saw, I've got that lower printing. This is the sister to it that's already printed. And you can see how shiny means smooth, right? How shiny this is coming out in ABS. This was actually at a 0.6 millimeter layer height using an 0.8 millimeter nozzle. And look at that detail. Not bad at all, okay? Even on the inside of this, this actually came out really nice without me having to do any post-production on it at all, okay? In fact, when it's finished, it comes out looking like this. And I've got a nice video on the whole process of how I actually designed and built this lower. So really high quality. This is something that the ones that you see me printing now are people from different parts of the country have asked me to make some for them. And so I print those out and make some extra money, which then pays for my printer. Another thing that I'm working on right now is I'm building a chandelier. So this is a sample of brass material that I've done. This came out really nice. This was just a sample to see how it would come out with the machine. And if it looked like brass, it does. It looks like brass. It shines up like brass. It's heavy as brass, almost as heavy as brass. And a ring for it for this chandelier that I'm going to be building. So we'll see how that actually comes out later. But the biggest project that I had was printing PETG through the Modix to print this hardtop convertible for my Jeep Brute, which works with the Jeep Gladiator as well. And as you can see, these were huge pieces, some of which had to be fiberglass together in order to be able to get the size that I want. I even ended up doing recovery boards for it too using PLA. Final review on the Big 120X Modix 3D printer. Great machine. You want to print big parts? This is a great machine to do it. Okay, if it fits inside the enclosure, you can print it. If you want to print it faster, use a bigger nozzle, right? You'll lose a little bit of detail on it, but the detail, as you can see with the 0.8, it's not that bad, right? This is actually a really, really great machine. So good, I'm looking forward to getting the second machine because I've got more parts I need to do, and I need to do them twice as fast than what I'm doing now. So anyway, wonderful machine. Hats off to the guys at Modix for being really there for you when you need them. And I hope you like this video. Give me a thumbs up if you like it. Follow me, and you can see some of the other big stuff that I've been creating with this. And sky's the limit on this machine. Thank you very much for watching.